Okay, what happens sometimes you see an integration, wonder how you're going to do it. You just maybe you just don't recognize it. But the bottom line is, I guess if you did a lot of work with the hyperbolic functions, you'd recognize this. All right, but I'm going to go through it with you. So I'm going to write down. Let's write this down. So hyperbolic sine of x equals e to the x. Let's see, minus e to the minus x over 2. And let me just do a little playing around with this. I'm going to say y because I don't write the hyperbolic sign down too often. This is e to the x minus e to the minus x over 2. And I'm going to try to get the arc function. And let's see if we can do that. And let's write this down. So it's going to be x equals e to the y minus e to the minus y. I can multiply both sides by 2. And what I'm going to do now, I don't know, it looks like it's pretty reasonable. I'm going to multiply, let me see what I'm going to do over here. I'm going to multiply both sides by e to the y. And you get 2x e to the y equals e to the 2y minus 1. Well, I think I can do 0 equals e to the 2y minus 2x e to the y minus 1. Well, it's quadratic, isn't it, in form? And, looking at it, let's write this down. 0 e to the 2y minus 2x e to the y. I'm going to take half the coefficient of e to the y, which would be minus x, square it. I would get x squared. And then I would have, minus x squared minus 1. Let's keep writing this over here. This is going to be e to the y plus x. That's plus x, sorry about that. I'm going to correct myself as I write things down. Minus x squared. That's going to give me this over here, by the way. If I square, you get e to the 2y. You get minus 2x e to the y, and you get x squared. All right, then when you get over here, I can write this as minus x squared minus 1. I use square root rule. Let's write this over here. E to the y minus x squared would equal x squared plus 1. It's a long road, isn't it? And if you haven't studied hyperbolic functions, you might say, where's this coming from? The study of hyperbolic functions. Get e to the y minus x plus or minus the square root of this. E to the y equals x plus or minus the square root of x squared plus 1. Don't despair yet, by the way. In certain sense, there's a lot of work, and you're not even halfway close to knowing something about the problem. But I'm just reviewing what the AP students would normally see in a classroom. Of course, their teacher would say, oh, you need to memorize this. And someone says, memorize what? Memorize the outcome over here. But I'm seeing something over here. I'm seeing that y would actually be equal to the natural log of x plus or minus. All right? There's trouble here, though, isn't there? And I'm looking at this thing, and I'm wondering, that can't really be possible. We got two different results there. And what I noticed about this guy is it has to be this one over here, that y has to be equal to the natural log of x plus the root of x squared plus 1. The argument of natural log's got to be positive. So I'm okay there. And so what'd you just do over there? I found the inverse. What's it going to be? Well, we started up there, so now I know the arc hyperbolic, the inverse of the hyperbolic sine is equal to this thing over here. Now, if you go back to the original notes here in the beginning, I want to go back over that and show you where that's written down for you. At least I hope it's written down for you. Maybe not. You know what? It's not written down. But the derivatives were written down. No, sorry about that. There's another set of notes I created. And go back to problem number 24. I mean, I was page number 24. I think I was on page 24. All right. So what I want to do now is I want to differentiate. And I want the derivative of this thing over here. So d dx of this would be d dx of the other side. So what do you get there? Let's write this down. It's 1 over its argument times, I get chain rule right, the derivative there of the inside. Let's write this down. It's going to be 1 plus, let's see, it's going to be 2 root of x squared plus 1. And then you can get 2x there, right? Boy, it looks complicated, doesn't it? So let's write that down carefully. Now the 2's cancel, that's convenient. And what do you get there? You get this. Common denominator. And what do you get on top? Well, look at that. You get root of x squared plus 1 plus x. Well, lo and behold, these factors will cancel off. And we're left off with 1 over root x squared plus 1. All right, let's go back. I know it was a long, like I would say a tangent I just took. And we're going back to this one over here. And what did we just basically show? I basically showed that this, when differentiated, would give me this over here, which is recognizable. So what does it mean? This guy's antiderivative is a known simple antiderivative. It's just simply this over here. This is why some of your teachers say memorization is so critical, that if you were on an exam and you were doing all this work over here, you said, what are you doing? Why don't you just remember that instead of doing all that work? But I always say it's really kind of more important to know how someone gets somewhere than memorization. But again, I might be in the minority of teachers, by the way. A lot of teachers believe that memorization is a critical skill, by the way. We're done with that? Thank you.